All right, guys, this is going to be our second set of radicals. On this one, we're going to be multiplying and dividing radicals. So we're just going to go straight into it because you know how to simplify them. So really, this is just one step before simplifying, and that's pretty much it. So when I'm going to multiply two radicals, what you want to do is you want to make sure you multiply radicands with radicands only and coefficients with coefficients only, okay? So for example, here I have radical 6 times 4 radical 8. So what I would do is, this is kind of like an imaginary 1, so I'm going to multiply 1 times 4, or just simply write 4, and then radical 48, 6 times 8, and that's it. That's all you do. And then now it becomes simplifying radicals like you just did on the first set of our radicals notes. So we're going to simplify this by just doing a tree. And so I know 16 goes into this, wait, does 16 go into 48? Let me double check on my calculator. I think 3 times, right, y'all? 48 divided by 16. Yeah, 3 times. So 16 times 3. And then I know 16 is a perfect square, so I'm going to underline, circle that and underline the 3. So the 4 is going to come out and join the 4, which makes it 16, and then radical 3. So this is the simplified answer of that multiplication right there, problem. Okay, so let's try it one more time. I'm going to show you something a little bit different on here. So we have a -6 being multiplied by -3. Remember, coefficients with coefficients. And so that's going to be positive 18. And then I have a radical, and I have 14 times 28. That's a rather large number. I don't even know how to do that one in my head. So here's what you can do when you work with such large numbers. You can actually just leave it like that under one radical, 14 times 28. And now it becomes a problem where you can simplify, you know, the 14 and the 28. Now, I know that 14 goes into 28 2 times. So guess what, guys? This right here, you can stop right there. Remember, once you get a pair, you can stop and circle that pair. You don't need to keep simplifying. You can if you want to, but since that is a pair of 14s, and then I'm going to underline the 2, and I'm done. So the 14 is going to come out and join this 18. And so here's my answer. I would have 18 times 14 as my coefficients, radical 2. Okay, so I don't know what 14 times 18 is, so I'm going to put that in my calculator. So 252. So my final answer is 252 radical 2. Okay, so much bigger numbers, but it's still pretty easy to work with. And that's it. That's all you're doing when you're multiplying radicals. Okay, now let's try multiplying radicals with variables. So you'll have to remember from Algebra 1, what do you do when you multiply variables, okay, with exponents. So as we look at this first one, we're going to multiply, again, radicands with radicands. So I have a 2x out in front, and then I'm going to write a radical, and this is going to be 18. And then what is x squared times x to the third? Well, if you remember from Algebra 1, you add the exponent, so it becomes x to the fifth. All right, so now I'm just going to simplify the 18 if it can, and I know 9 times 2, 3 times 3. I'm going to circle that, underline the 2. Here we are, what we did back on the first set of radical notes, simplifying that. I can take half of 5, and half of 5 is x to the 2.5. So 1x will be underlined, and this one, x squared, will come out in front. Again, if you don't remember that, look what you can simply do is just simply expand x to the fifth. So 1, 2, 3, 4, 5. Circle, circle. How many did I circle? 2, like I have right here. I have 1 underline, which I had said at the beginning as well. So remember, either way is fine. Okay, so now I'm going to write my coefficient out. So I have a 3 joining the 2, which becomes a 6. So does everybody see how I got the 6? This 3 is out here with the 2. And then I have x squared and that x. So that's going to become x to the third power. So what all did I underline? I underlined this 2, and I underlined that x. So that is going to be 2x. And so here's my final answer when I multiply that problem right there. My final simplified answer. Let's try it one more time. This one has a lot of letters. So remember, I can only multiply coefficients with coefficients, so that's going to become a negative 12. A times A is A squared, and then I have a B squared out in front. So what is my radical going to be? I have a 9 and an 8, so that's going to be 72. I have an A. I have a B squared and a B to the third, so that's B to the fifth. And then I have a C. All right, so I multiplied it. Multiplying is the easy part, and now it's just a matter of simplifying. Okay, so now I'm going to simplify this. So I know 36 goes into 72 twice. I like 36 because that's a perfect square, and I can stop right there and underline the 2. A is going to end up staying underneath the radical as well as a C because there's only one of them. However, look, there's B to the fifth again, and I just did to the fifth earlier. And so remember, half of 5 is 2.5. So B squared is going to come out, and then I'm going to have a half of B, which is like that right there underneath. Okay, again, if I want to expand it, I can. 1, 2, 3, 4, and 5. Circle a pair, and you can see how that 1 gets underlined, like I had said. And then 2 came out in front. Okay, so I've got all my circled stuff. I've got all my underlined stuff. Now let's simplify this. So this 6 is going to come out and join that 12. So what is 6 times 12? That is 72. So I'm going to have negative 72. And then I have a squared still. B squared is going to join another b squared. So b squared times b squared is b to the fourth. And then I have my radical coming up next because I don't have anything else going out there. And then I have a 2 underneath the radical. I have a B, and a C. So A, B, C. And that is my final answer when I multiply that multiplication problem. Okay. All right. So now let's divide radicals. This one's a little bit more challenging. I don't think you've seen this before, so this will be probably new to you. Okay. So whenever we divide radicals, there's 2 rules that we need to remember. Okay. We can't have no radicals in the denominator. Okay. So let's write denominator right there. All right. And so if there is, I'm going to show you what to do. And then rule number 2, no radicand is a fraction. So let's write fraction. So if this ever happens, this is what you're going to do. So for instance, case number 1, I see a radical in the denominator. So how do you get rid of it? Here's how you get rid of it. You multiply by the number 1. Okay, so if we're multiplying by the number 1, we're not changing its value. But the way we're going to write this number 1 is related to the denominator. I'm going to multiply by radical b over radical b. Okay, radical b over radical b is simply the number 1. Okay, but I want to use this because you're going to see how it disappears here in a second. So a times radical b is just simply a radical b. Radical b times radical b is just simply b. And that's it right there. So now you can see how I got rid of that radical. So let me show you why, because some of you guys may not understand what radical b times radical b is. So radical b times radical b is radical b squared, right? Well, we just talked about how to expand that variable. So that's 2 of them, and that's 1 number that comes out, okay? Also, you guys probably remember that radicals and squared cancel each other out, okay? So let's look at case number 2. I see a radical and I see a fraction under the radical, okay? So here's what you do here. You want to split it apart like this. And then now it takes us back to case number 1, which we have a radical in the denominator. So I'm going to simply multiply by the number 1, but the way that number 1 is going to look like this, radical y over radical y. So then on the numerator, I'm going to have radical x times radical y, which is simply radical xy, and radical y times radical y is just simply y. And now there's no radical in the denominator. Okay, So let's try some examples like that with numbers and variables. So over here I have 6 and then I have a radical 8 on the bottom. So I have to get rid of that. So what am I going to do? I'm going to multiply by the number 1, but the way I'm going to write number 1 is related to this. Okay, so radical 8 over radical 8. So now let's multiply straight across. I get 6 radical 8 on the top, and I get just 8 on the bottom. Okay, because remember, radical 8 times radical 8 is radical 64, but then what's the square root of 64? 8. Okay, so when this happens here, you want to simplify this fraction, and you want to make sure that you can simplify the radical all the way through, okay, or make sure that it is simplified. And so I can tell right there the 8 is not simplified. So I'm going to come over here off to the side and simplify the 8, which is 4 times 2, circle, underline. So I need to replace that radical 8 with the simplified answer. So here's what I have. I have 6, and then I'm going to write times 2, radical 2, all over 8. Well, what is 6 times 2, guys? It's 12, radical 2 over 8. Now I can simplify this fraction right here. So what number goes into both of those? 4. 4 goes into 12 3 times, and 2. So my final answer for this dividing over here is going to be 3 radical 2 over 2. Okay, and that's how you divide by a radical 8. Let's try the second one over here. I have a big fraction under the radical. Now let me tell you something. If you can reduce this fraction, I would highly advise that you do that, okay? And so both of those are even numbers, and so 2 goes into 8 4 times, and 7. So you want to simplify that because you want to work with much smaller numbers if you can. All right, so now remember what I said earlier. You want to split these up like this. And so now I'm going to multiply by radical 7 over radical 7. Now, if you forget to simplify it, you can. You're just going to be, you can still simplify it. You're just going to be working with much larger numbers. So radical, why did I put a 2? Let me go back and fix that. Radical 7 over radical 7. All right, so now what is radical 4 times radical 7? Well, think about it, guys. Do you want to multiply 4 times 7, or do you know what radical 4 is? Radical 4 is simply 2, right, everybody? So 2, radical 7 is going to be on top. All I'm doing is simplifying that radical 4. What's the square root of 4? Everybody knows that. It's 2. And it's going to be over 7. So see, you just avoided yourself having to simplify radical 28 because it's going to take you back to this. And then I'm done there when I divide and simplify that radical. Okay, so remember, you can't have a fraction in a radical. All right, let's try these last two, and then we are done. So here's another thing to remember. Okay, so remember we simplified this 8 and 14 to 4 and 7. Well, you can simplify these two as well, okay? This radical can simplify with that radical. So doesn't 3 go into 18 evenly? It sure does. So 3 goes into 18 6 times. So I have 2 on top. I can write radical 6, and I have a 3 on bottom. And I can't simplify the 6 anymore, so you can actually leave your answer like that. So sometimes when you see a radicand, you can divide it into another radicand, okay? So that one was rather done quickly. So remember, when you can divide radicals by radicals, yes, you can do that, because then it'll totally save you a lot of time, because a lot of students will multiply that by radical 3 over radical 3. But remember, you can divide that out. So let's look at this one over here. Last one. This one has variables, okay? So you'll have some variables at times. So I have a 9, a to the third on top, and then I have a 5, a radical 5, a squared, b squared on the bottom, okay? Now, if you can simplify these radicals, then you should. Like, everybody knows the square root of 9 is 3, so I'm going to take the 3 out. And then I have a to the third, okay? Well, remember I taught you you can expand it and circle the pairs. Well, an a is going to come out and join that 3, and then I'll have 1 left over. So I'm going to have an A there. Okay, over here, A squared, remember A squared is A times A, B squared is B times B. So these two can also come out. So an A is going to come out, a B is going to come out, but that radical 5 is not. So, but it makes it a lot easier, okay? So if I have this A and this B and it's out, I don't need to multiply by that, okay? And so this right here, radical 5A squared B squared, this is the simplified version of this. And so now I only have to multiply by radical 5 over radical 5 to get rid of the radical in the denominator, rather than multiplying by radical 5a squared b squared over 5a radical 5a squared b squared. Okay, so if you need to write a little note, put a little note, put simplify first, exclamation point. Okay, just like here, we simplified over here, the 3 into the 18. Over here, we're simplifying the radicals first to make it easier. Up here on this problem up here, we simplified this fraction. So simplify first if you can, okay? So simplify radicals or fractions first, okay? So maybe I shouldn't say that. Simplify radicals or fractions first before you divide, okay? So before dividing, okay? All right, so now I'm multiplying by radical 5 over radical 5. Remember, you can only multiply radicands with radicands. So my numerator is going to have 3a, and then my radical is going to be 5a over. Well, what happens to the radical 5 times radical 5? It's just simply 5. And then I have an a and a b. Now, there is one last thing that I can simplify, guys, and that is if you have an a on top and an a on bottom, they cancel out, okay? Because a divided by a is just 1. So my final answer is going to be 3 radical 5a over 5b. I have no radicals in the denominator, and it is good to go. Okay, so remember to simplify first, and it'll make life easier, because if not, you're going to multiply by that big radical on the top and the bottom, and you'll eventually get to this answer here, but it's going to take you a little bit longer. Okay, I think that was the last example. Yes, it was. Let me make sure it's not down here. Okay, and that is dividing radicals.